Have you guys run into this before? So Postgres, okay, so do you know what a null value is, first of all? So the idea behind a null is, like if you're thinking about strings, so I have some characters I'm going to store. Maybe it has the name Jeremy, maybe it has the name Divya in there, or it could just be an empty string, right, if there's no name. The empty string and the null are very, very different. A null value, and I think that the important thing to think about is that, so the SQL language was designed by a mathematician, and there's a lot of sort of theory behind the SQL language. There's two different ways to think about a null value. One way to think about a null is sort of probably the programmer way of thinking about it, if you have like a programming background, is it just means that there's not a value. It's like not there, right? That's kind of what a null usually is like in C, for example. If something is null in C, that means it's not there. That is not a null value in SQL. SQL has a different definition. What null value means in SQL is it means I don't know what it is. And that's a very important distinction. It particularly comes in, let's see what kind of slides we have here. When you sort of look at three-valued logic, so if, let's just think about like a Boolean variable. This is something I could probably whiteboard, but I'm not going to. If you think about a Boolean variable, and let's say that I'm doing just a simple Boolean operation where I say x and y, and that's what I'm doing. OK, well, if x is true and y is true, then what is x and y? It's true, right? If x is true and y is false, what is x and y? Be false, because they're not both true. What if x is true and y is null, but null just means there's no value? Well, then it would be true, because I just don't have anything over here. So everything that I have is true, and I'm doing an and, right? What if it's saying unknown? OK, if it's I don't know, then what is x and y? Well, I actually don't know is the answer, because it depends on what y is. And if I don't know what y is, I don't know what the answer is. So that means x and, so if you're working with a definition that it's I don't know, then the answer has to be I don't know. So x and y. So in SQL, if you have a null value inside of an and operation, then the answer is going to be null. That's the sort of logical way to think about a null value in SQL. OK? Now, that's how it is. That's how you're supposed to think about it. That's sort of like the formal idea of what a null value is. It's an unknown. The way it's actually implemented, unfortunately, is different between Postgres and Oracle. Most often seen with string concatenation. I actually didn't know that. That's useful to know. So we're going to set up a short example here to illustrate this, where we have a table with a first name, middle name, and last name. And we're just going to concatenate those three columns and put spaces. So this is basically a SQL saying, give me the full name of somebody, all right? So here is what happens when we run that SQL in Oracle. OK? And notice what's going on here. How many people have a middle name? Just the bottom guy, right? William Henry Harrison. He has a middle name. Everybody else just has a first name and a last name. Nice. They're presidents. American presidents, excuse me. All right. So we have 10 rows in Oracle. Now what happens if we run exactly the same query in Postgres? All right. I'll give you just a moment to guess what you think it's going to be before I show you. You have a guess in your head? What do you think Postgres is going to do? All right. That's what you see in Postgres. Oh, 2 of them have middle names. Yeah, you got nothing. So Postgres is actually, and this is where, and I've seen this in other areas too, Postgres is doing the thing which is correct technically according to the SQL standard. Oracle, if you didn't know this, does not do everything correctly. They're very pragmatic, though. They've kind of done, in many cases, done what people wanted them to do instead of doing what like the mathematicians say they should do. And this is an example where that has happened. So in practice, like when you're writing applications and you're concatenating a string, this is a super common thing for a programmer to do. And you know what he really wanted was this, right? So Oracle's like, fine, I'll give him this. Postgres says, no, you asked for that, and I gave you that. You know, I'm just doing what's mathematically and algorithmically correct, and you should design around it. So if you want to have that in Postgres, what you actually need to do is you use a function called coalesce. So what coalesce will do is, in this example, there's 2 parameters, but coalesce will actually take as many parameters as you want to give it. You can just make a list with commas, and just the first one that's not a null is the one that comes back. So does it make sense? You could put like 6 variables in there. If the first 4 are nulls, then the 5th one will come back. And that's the coalesce function. Very important function to know about. So here we just wrapped the first, middle, and last name in coalesce in Postgres. And now in Postgres, we have the same answer that we wanted for our application. Data types. Give me just a second here. You can edit that out. So data types. Oracle has a few main data types that are typically used. And then it has a couple of large object types. That's right. Now we're going to get into dealing with some of that. And this next slide is great. Okay, so here's the Oracle data types, the ones that, like, you almost, like I said, your string, your date, your number, your key ones, and then for large objects, these. What does Postgres have? This is what Postgres has. All the data types, right? So Postgres, it comes with 64 base types, and you can extend it and add even more. Now, technically, Oracle does have a few more than this. I mean, you know, this is sort of a fun slide that we put together. Oracle does have a few more, but in practice, that is, well, and there's a couple really key differences, which I think we're going to get into. The point of that first slide is, though, just, you know, it's just kind of check your assumptions around data types. They are very different, and they behave very differently. CLOBs are, so CLOBs are one of those big areas. So in Oracle, if you want to deal with a very large amount of data in a column, you have to use this thing called a CLOB, which stands for, so the LOB stands for large object. And then in Oracle, there's 2 different kinds here. There's the C LOB, which is character large objects, and then there's a binary large object, so blobs. And what we say, the lingo that we use is clob and blob, is how people say it. That's in the Oracle. And the way that those work in Oracle is that when you have a column, which is the data type clob, you actually have to use like these, you have to almost always, to do anything meaningful with it, you have to wrap it in a function and like use these functions to do it. It's actually kind of cumbersome. It's kind of a pain. In Postgres, it's completely different and way easier. Because we demonstrated this yesterday. We looked at the text data type and we looked at toast, right? And how it can move things out. So in Postgres, the text and varchar actually handle the huge columns. So yeah, you have in Oracle, the maximum possible length of a varchar is around 4,000 characters. In Postgres, this is awesome. Like you can hear, they've created a varchar with a maximum length of 10 meg, which you can't do in Oracle. You cannot put 10 megabytes in a varchar column. So this is actually a huge thing. If you see people struggling here, they might be coming from a different database, and they just might not even know that they can store so much data in a varchar column. That's super common. All right, this is demoing that functionality. All right, now we get into numeric. Numeric is the next one, and this is actually hugely, did we talk about this earlier this week? I think I might have mentioned it. Okay, so I'll kind of skip over some of those. Analyzing. All right, this gets into migration, sort of the process of doing migrations. I'm going to just skip over some of this for you guys, since it won't be super relevant for what you're doing. So candidates, third-party applications are things that you can't really control. You're probably not going to do a lot with those. There is a good point here, though. I think with all of this, homegrown applications, you have older applications, that migrating to Postgres is really about migrating applications, not migrating databases. That's really what it is. And I spend a lot of my time sort of at the database tier of the stack, and and maybe you guys will too. If you end up sort of in a similar situation to me, it's a good thing to sort of be respectful and kind of just recognize that people are spending a little bit of time with us on the database, but they're spending a lot of time not with us, just in their applications. You know, like we as a database, the database is really important. I mean, like, because we're, in a way, it's the custodian of the data. It's what keeps the data safe, you know. There's an interesting parallel here if you keep track of like containers and Kubernetes, and kind of our whole industry is kind of going through this shift right now toward containerization and container management. And that's really cool, but it's interesting how there's still kind of a split between like the application tier and the data tier. And like at the application tier, like when you look at just the whole value proposition of containerization, like what makes it amazing is that people can just like throw them away and provision new ones, kind of like what EC2 started back in the day with AWS, what made AWS what it is. But that kind of fundamental thing, like that's very different, right? You know, the whole like premise of a database is that like sort of the opposite of that, you know. Whereas with applications, like it's world changing. I'll just throw it away. Like that's awesome. Like you don't just throw away your database, right? You know, that's like we're actually like it is actually a real sort of, it's an interesting juxtaposition. They're really opposites of each other. You know, in the database world, it's not we're actually trying everything we can to do the exact opposite of the thing that we want to do in the application layer. So it's good to be just sort of understand that kind of the two worlds, that we need each other and we need to work together, and really kind of we're one world in a way, but it's these two different layers of the stack. And when people are migrating, it's the top layer is where all the time and the energy is. Sometimes even migrating is not even about migrating an application. Sometimes migrating to Postgres is about changing your business processes, which is the layer even above that. You know, your business processes, so you can just switch to an entirely different application that actually works with Postgres, or a different application which just makes more sense for your business, and maybe it just happens to use Postgres in the back end along with two other databases. Because maybe the old application you were using only used one really expensive, you know, stack. Could have been just locked into even to hardware level. You know, there's some applications that are locked into just like you buy this rack that comes off the back of a truck into your data center, and that rack is your, you know, it runs all your HR and your ERP stuff. And that's just, you know, it's really expensive, and it will, but on the other hand, if you're like $1 billion company, maybe that's, you know, a good price for you. It does what you need for a better price than any alternative. But these things change over time. Other candidates, large data. I don't know. These I honestly feel like data movement can become a factor in migration. I don't think that's really a big one. There are really large, I mean, like even when you're talking about terabyte scale databases, I still kind of feel like we can probably figure those challenges out. I hope you guys get to work on some really big migrations someday because they're fun. Solvable problems, right? And like I said, the level of complexity of like solving this problem is nothing compared to the level of complexity that we deal with at the application tier. Downtime window. This is not, now we're getting to the easy problems to solve in my opinion. Logical replication, great solution for that. This gets a little bit more tricky. This comes back into another sort of important thing to think about is features. Where if you have an application that's leveraging certain things, this will go to differences. And these are some good examples, very specific areas like spatial and XML, or flashback, for goodness sakes. Flashback query is a capability of Oracle to run a query, and like your query can go back in time and run as of a time in the past. So for example, in Postgres, if you could say, you know what, I just connected right now, make a new connection, but I want you to like run this query and like just make the query run as though it were running 5 minutes ago. And in Postgres, actually, if you blocked vacuum, that would work, right? It could read the old rows, but we don't. That's not a good solution. There are, by the way, if you needed a similar capability of flashback, there are a number. There's something like called shadow tables you can do. There are a number of like auditing solutions that people have built, because that's often, this is tied to auditing types of things. Or if you have heavy like regulatory requirements to keep every version of data, every time a change is made, I need to keep all the versions. So the auditors, when they come in, they can see the way the data looked a month ago, and they can see it now and just verify things. So that's often compliance driven. And there are solutions for Postgres out there. And there's some good talks from some Postgres conferences about that, if you're ever looking for that. The data access pattern. This is when you characterize, what this really kind of reminds me of is that we've talked about AWR reports a couple of times. The very top section of an AWR report, there's the top section just like identifies your system. The section right underneath that characterizes the workload with a few really simple just metrics, like the commit rate, how much redo are you generating, or how much archive logs, what's the call rate, so like how many queries per second are you getting, that kind of things. And it's a really useful thing to be able to just characterize a system, kind of just be able to say, give a general description of what a workload is like. This fits right into that. So, and it's kind of like just when you get on the phone with somebody and you're trying to help them with their system, one of the first thing you want to do just is describe your system to me. Tell me about what does this database do. And this is some great vocabulary for that right here. Do you have batch jobs that run, large batch jobs? Do you have reports that run once a day or once a week? Or do you have certain, there's always going to be a cycle. There's going to be multiple, but there's going to be a daily cycle always in any system of just, if you were to sort of step back, kind of like our performance lab, like when you looked at the performance lab, you could see a cycle of it would get kind of busy at one period and it would get idle at another period. And that's very reflective of how real-world systems look. Real-world systems have these different cycles that maybe there are sort of certain periods where maintenance operations run, a backup might run at a certain time every day. In RDS, you have your backup window, which you can configure. You have a maintenance window that you can configure. And then these other things characterize the workload. Is it mostly like read with just a couple of writes? Is it append only, meaning that you never modify a row that's in there, but you only add new data? A lot of like financial places work that way. Again, for compliance reasons, that I would never change a record. Once a record goes in there, it has to be there forever. It cannot be removed. So that could be an append only system. Update intensive, meaning that like if I just look at the number of records in the table, it doesn't change very much over time. It's usually just updates to it. And then you have this idea of insert and purge, where that sounds like a queue, right? Like you can have a queue where it's first in, first out, where you're inserting new records, and then as they get processed, you're pulling the old ones out the back. That's another really common pattern or design pattern or workload that you can see in a database. Those in particular, that pattern is one to look out for in Postgres. The insert and purge, there are some definite, if somebody's doing that, hop on the web, there are some definite best practices. And I want to say that just a lot of people have chosen poor approaches to that in Postgres. So that's one where there's probably opportunities for improving performance by learning a little bit about the best practices and bringing them back to your system. The language matters a lot. Now this is talking largely about the upper half, but then you've got language in the database as well that you need to factor in. ORMs deserve a special call out. An ORM is an object relational mapper. All right, if you're not familiar with those, either object relational or an object relation, I'm not sure which, but the ORM, what an ORM is it's either very useful or very evil, depending on your perspective. But what it does is, if you're a programmer in an object-oriented programming language like Java or C#, what an ORM does for you is that you start writing code, you never write any SQL. Instead of writing SQL, your data that you want to deal with just shows up like an object. And you would just say, like, create a new employee object. And then when you create that new employee object, all of the sort of programming framework handles sort of, oh, that person's trying to create an employee object, so I will go insert a record into a table, right? And then if you say, like, now from that employee object, give me the department that employee is a part of. And you would do that using just normal programming language of saying, like, employee.department, equals 51 or something like that. And then the framework, excuse me, the framework sees what you're doing, and the framework figures out, oh, I need to translate that into a join on this record over, and then pull this record over here. It's very convenient in a sense from a programming perspective, mostly convenient in that you as a programmer don't need to really deal with the database. And it can be sometimes useful just for like being able to just get some code out really quickly, and to be able to like have some code that, or if you want to have code that's like can be just maintained without any database expertise or any database knowledge. ORMs, though, because what happens then is like nobody knows anything about the database. Nobody's usually not writing any database code. So it's all computer-generated SQL. What could go wrong, right? A lot of things are not optimal. So ORMs are just kind of notorious for generating SQL statements that just are not great SQL statements. Like one example was the one that we talked about in the hot update thing, where the ORM, because it's all computer-generated SQL, was updating every single column, even if the value never changed when it did an update statement. Luckily, Postgres is smart enough to recognize that, as we saw. So that's ORMs. Yeah, what you end up having to do at the end is you're going to have to scan over and kind of try to assess the whole situation. There are a couple of interesting tools for this. I mentioned SCT. There's also one called Aura to PG. That's another just open source tool that you can use that'll scan an Oracle schema and create sort of an assessment of whether it can migrate over easily or not. All right. So we've got a section on testing, and I'm just going to flip through these slides really quick, and you guys just watch. If you see anything that you want me to pause on, let me know. But this is kind of application side stuff, talking about unit testing here. There is a test framework. This does, though, sort of remind me, in Postgres, there's something called PG-TAP, T-A-P, which is a testing framework for like automating tests on Postgres. We just added that to RDS Postgres. So that might be something that you could check out sometime, read up on a little bit. PG-TAP, PG-TAP, T-A-P. So pgtap.org, right here. So it's a suite of functions that make it easy to write tap-emitting unit tests. The tap is actually, and tap is actually a like more of like an industry thing for testing. So yeah, this is pretty cool, and this is now supported on RDS Postgres as well. So that's tap, and then if I keep going here. But yeah, you got some stuff on unit testing. This is kind of about how to write tests, but I'm going to skip over some of this. Data validation, determining the amount of validation required. If there's anything here that you want to pause on, let me know. To be entirely sure all the data is migrated accurately, checksums should be calculated for rows and columns, yes. And there's tools available for that. All right, that, believe it or not, is the end of the slides that we pulled in for the migration-related stuff. And that's just about right exactly on time for what we were aiming for. What questions? So this is the end of the content we have. We don't have a 3 o'clock session this afternoon, planned at least. You could always see if Scott wants to hang out on Chime for a while. He might. He might go for it. But do you have any questions from this or any other topics you want to hit on before we wrap up?
Yeah, just one about the logical replication.
Mm-hmm.
So, you know, like how you said the wall sender is smart enough to detect and then send it.
The wall sender is smart enough to detect and then send it, yeah.
Yeah, right. And then you talked about the publish and subscribe. Can you just go over that just once again?
The publish and then, yeah, and then I talked about the publish and subscribe. Yeah. And I'm just repeating so it gets picked up. The publish and subscribe specifically, is it like, would you like to see an example of what that looks like in Postgres? Like just pull it up in a database and create one? Or was there a specific question about what pub sub means?
Yeah, I didn't get the difference. I mean, is it just like, so for the wall sender, it will send it to whoever is, however wall receivers I have.
Yeah.
So a subscriber means that I have to subscribe to that topic or table, or how is that different?
How is the pub sub different from sort of the wall sender? Yes, okay, that makes sense. Let me pull up that slide. Let's go back. Just because it has these two slides here. So that one and this one.
Yes.
Yeah, so these are, okay, I see what you're saying. You're kind of asking how the publication and subscription, where that overlaps with this wall sender process.
Exactly.
So, yes, okay. So this wall sender piece, and I've drawn 3 transactions that are happening, and the wall sender is keeping track. That's all sort of implementation. That's a layer down from, so this is logical decoding, which is a completely different layer from this, which is publication and subscription. So they're not, I think the important thing here is that the wall sender, like when you do a sort of a create publication and create subscription, you're not, that has nothing to do with transactions in any of this. Okay? So I think that the best way to illustrate this is actually just show you what create publication and create subscription are, or sort of what they look like. Let's, for starting out with that, let's just go pull up the doc page for that. For create publication. When you create a publication, you're publishing a table, is what you publish. And that's really all you publish. So you have 2 choices. Hold on. I just realized this is not on the projection screen. It's on my laptop screen. OK. So bring this over. You have 2 choices when you create a publication. You either can specify a table or you say for all tables, and that's it. And the main difference, you can give a list of tables, but if you say for all tables, it'll pick up new tables as well. So when you create a new table, that'll just get picked right up in the subscription. See? So you're not creating, so you create a publication and a subscription for a table. So my test table, I want to publish this table, and then over here on another database, I'll subscribe. Well, okay, I almost think it's, I'll do it in a text pad. Is what I'll do. So what I have, where's my mouse? Bring it over here. OK. All right, so what I'm going to do is I can create, so I'll publish something called Jeremy dash, no, we'll call this PG Masters. All right, the PG Masters, so actually, let me even do this a little bit different. We'll have PG Masters publication, all right? Inside of the PG Masters publication, we've got the Dublin table, first name, last name, okay? And then we've got the Cape Town table, first name, last name, columns, right? Seattle table. Okay, so that's my publication. And then what I do is down here in my, and then I have a database called prod, right? So now, down here, I'm going to make a second database called reporting database, right? So this guy's where I can run some reports. And then I say over here, subscribe to PG Masters. I want all the PG Masters, okay? And then I'll say subscribe to PG Masters, all tables. Oh, sorry, not all tables. You just give a subscription. That's all. Okay, now what happens when I do that, I say that, is that now under the covers, first, Postgres is going to, in the reporting database, it creates 3 tables, right? Dublin, Cape Town, Seattle tables. Then, now, okay, here. Now I log back into my prod1 database, okay? And I insert into Dublin. Well, here, first Seattle. Insert into my Seattle table. Values. And we'll say Jeremy S, right? So I put that into the Seattle table, all right? And then I commit. At this exact moment that I say commit, Postgres now, in the reporting database, it does insert. So in the reporting database, it's going to do insert Jeremy commit. That's what it's going to do, okay? Now, in prod1, that was there. Now we're in prod1, and we do insert into Dublin values. Let's see, Divya. What letter does your last name start with?
S.
Starts with an S. It's a great letter to start your last name with. And of course, we also insert using the Postgres syntax, which is awesome. Mohammed, right?
Yeah.
Mohammed N, right? So Mohammed N. I don't. There's like 6 ways to spell Mohammed. You're just going to have to live with the A's for today.
Yeah,
so, yeah. All right. So I'm sure that that's not the right one. I apologize, but I know it's right for somebody. So let's see. So we do that. Actually, no, and I actually don't want to do that yet. Hold on. Actually, I'm just going to do Divya right now. Not because you don't know about Postgres, Mohammed. So we do Divya. What happens now? Here's the question. Did that record get inserted into the reporting database yet? Well, because what if Divya then fails the exam? Oh, so now I have to roll back, right? I mean, but Divya's not going to fail, so we won't do that. She's going to pass with flying colors. But the important thing is, like, we don't know yet at this point in time whether that's going to commit or roll back, so we do not yet put it. And this is very, very different from physical replication. If this was a physical standby, then Divya, her record would be stored on the disk on the physical standby right away. Okay? And it wouldn't be marked committed, but it would be put on the disk. In logical replication, nothing is sent to that logical replica at all yet. Okay? So with logical, nothing happens. So next I do insert into Dublin values, and we put Mohammed in there. And then I do a commit. And this is the point, the moment in time right here where now, and this goes back to like what I was describing. So like you were asking what's the difference between these two things. Well, the wall sender and the wall worker, like those are, that's kind of how it works. The create publication and create subscription is at a table level. That's kind of what we saw here. And even more than that, like a publication can include multiple tables, not just one. Can have more than one. This is sort of the mechanism of how it works under the covers. So this is where it's that wall sender process. Actually, what's happening is that those inserts that we did are these little squares. Each of those inserts is stored in memory in a buffer for your transaction. There's a value. I don't know what it is. It might be like 4K or 8K. It's in a different presentation I have. There's just a certain amount of memory. Once it gets to that amount, an individual transaction gets to a certain amount of memory, then what happens is a wall sender spills the transaction to disk instead of keeping it in memory. That way it doesn't blow out the memory. So at the moment we do the commit in the reporting database, now is where we do the insert, Divya, insert Mohammed with 2 M's and 2 A's. And then we commit. So that's the workflow. And does that kind of help a little bit of logically showing how it works? So yeah, we have the 3 tables. And both tables were included in just a single publication. And then over here, all we did was subscribe to, and we give the publication. You can't pick your tables when you subscribe. When you subscribe, you're just going to pick your publication. And then you'll get, so if you want, the place you control tables is when you set up the publications in the first place. That's where if you want a way to just do the Seattle table or just do the Dublin table, then you would just make separate publications for each one of those. Another sort of quirk of how this is implemented in Postgres is that each subscription, let me think about this. Each publication, yes, that's exactly where I was going. Man, you're already like 10 steps ahead of us. Yeah, each publication creates its own publication slot. I have to repeat it though. So yes, you're going to be adding slots for each one of these.
And it does not replicate DDL statements?
Correct. No D. Well, it will. It caught the create table.
I don't.
Actually,
you can do it on a.
No, I think you're right. So the thing is, when you do create all table, I think you're right though that it does not do DDL. This doesn't. Now this is where PGLogical is different. Yeah. PGLogical will capture the DDLs and actually create the tables on the far side for you. This will like include. I suspect what's going to happen is if you create a new table and you've used all tables, then I think what's going to happen. Although we should just test this later. I think it'll just stop applying. This is although this is another kind of like weakness with the native Postgres replication in version 10, and I need to read the 11 release notes and see whether they've addressed it there or not. I don't know. But in version 10, for sure, when replication gets stuck, like it can't do an apply, so that's actually not hard to do. There's about like 100 different ways you can get it to where replication gets stuck. Like if there's a conflict, if it can't find a row it's supposed to update, if it can't insert the row in the first place, you change the indexes, change the data types. You can do a lot of interesting stuff. The flexibility is really useful. Like for example, you could You could use this to, shoot, you could even make a publication and a subscription where it's on the same database. There's no reason you couldn't. You could actually put the subscription in the same database that subscribe. Oh, wait a minute. But the table names have to match, so you probably can't do that. If you couldn't remap the table names, then you could. But you can do this across databases, and you can use this to do changes to the table. I think the table names and the column names have to match, if I recall correctly. But the data types don't. So you could change a data type, and there are some other ways you can make changes to the schema within reason. But if you change it and then it can't apply a record, it just gets stuck. And then now you have the replication slot that you have a problem with. So you might end up having to drop it at some point to free up the space.
I have a couple of quick questions.
Yeah.
This is finished. It's just quickly, like we don't have to worry. Aurora is using geological, or I think geological.
Aurora, so we just released logical replication on Aurora, outbound logical replication. The initial release did not include PG logical. So PG logical, that was like, we just released that, and PG logical should, I think they're targeting, I'm pretty sure they're still targeting to have that out this year. But I don't remember the PMs. Check with the PMs for the date.
Like the native one, or? Like
yes, the native one. This is what we support. Yeah. Well, and more importantly than this, we also support all the decoding plugins. Sorry, not all of them, because we don't support the PG logical one. It has its own plugin. But we support the one that DMS needs. So DMS works.
Okay.
That's what a lot of people are using. They're just plugging DMS in, and that's what a lot of people were looking for.
One more thing, sub-transaction.
All right, tell you what. Since that was from yesterday, let's hold off on that for a moment. Were there any, I just want to close this off. Anything else on today's stuff? Cool. All right. Great, thanks.